Question 9. The diagram shows the curve with this equation. Part A. Find the equation of the tangent to the curve at the point where x is equal to 3. Give your answer in this format here, where A, B, and C are constants. Now, something very important here we need to do is to differentiate, okay? Remember, the gradient of a tangent at the point of intersection with the curve is going to be the same as that of the curve, okay? Now, we need to if we need to find the equation of a straight line, we need its gradient and also at least one point through which a line passes, okay? So for x is equal to 3, because we know the x coordinate, what will be the y coordinate? So for x is equal to 3, what will be y? That will be the square root of 2 into 3 cubed. 3 cubed, then plus 10, okay? So 3 cubed is 27 times 2. That one will give us 54 plus 10, 64. Square root of 64, that will be 8. That means the point is 3, 8. Remember here, our y is equal to 2x cubed, then plus 10, and then it will be to the power of a half. So when we differentiate that one, we shall have a half dropping down, then 2x power 3, then plus 10, and then we reduce this one by 1. So a half minus 1 is negative a half. Then times, you enter inside and differentiate this one, which is going to be 6x squared. So 2 can go into 6 3 times. That means we can have 3x squared. And then this one, I can take it down, okay? That one will be a square root of this 2x cubed, then plus 10, okay? The power that I have. Now for x is equal to 3, what will be the value of dy dx? So the value of dy dx will be put here, 3, then into 3 squared. That one, of course, will give us a 27. And then down here, we have 2 times 3 cubed. 3 cubed, that will be 27 times 254 plus 10. That is 64, okay? And then square root of 64 will give us 8, okay? Now, that is the same as the gradient of the tangent. Now, let's find the equation of the tangent. Equation of tangent, using the general equation, we have y minus y1, which is equal to m into x minus x1. So we shall have y minus, our y1 is the 8 here, then which is equal to m is 27 over 8, then into x minus, our x1 is a 3. Now, we can cross multiply. So when we cross multiply, we shall have 8y, then minus 8 times 8, that will be 64. And then when I open brackets here, we shall have 27 of x, then minus 81. Then I can take everything this side, or I can take whatever is this way, this side, okay? Because the constants here, a, b, and c, are integers. So the value of the coefficient of x can be a negative or a positive, okay? So putting everything onto one side, we shall have 27 of x, then minus the 8 of y, then minus 81, then plus 64, which is equal to 0. And we get our answer as 27 of x, then minus 80y. This one will give us negative 17. So negative 17, which is equal to 0. You can also write it as maybe multiply all through by negative 1. That is if you brought everything this side, okay? You can have negative 27 of x, then plus 8y, then plus the 17, which is equal to 0. So whichever way, okay? That is that. Part B, the region shaded in the diagram is enclosed by the curve and the straight lines x is equal to 1 and x is equal to 3. And y is equal to 0. Find the volume of the solid obtained when the shaded region is rotated through 360 degrees about the x-axis. Now, when we go back to our diagram here, when we rotate this one about the x-axis, this one is going to look like this, okay? And then you form, it's like when you're having a stick that is like this, and then you keep on rotating it, you will find something like that, okay? Now, we are going to strip this one into very many strips here, which will approximate to the cylinder. Okay, when we do that, if I can pull out the cylinder here, a cylinder in here, the cylinder is going to have the radius. Okay, so I've pulled out this cylinder. The radius will be this one here, right? That radius here is equal to y, because this is a y value. You see that? And then the height is going to be this one here. Okay, that is the height. Now, which will be this one here, and that will be the change in the x values. You see that? So the change in the x values, our height is therefore going to be that dx. Actually, we represent it with delta x. You see that? And we know that volume of a cylinder is equal to pi r squared h. Not so? If it is pi r squared h, then that means that volume of just one cylinder will be pi, r is y, and then the delta x here. Now, to get all of this, the volume that is generated, then I'm going to add up all of these. I'm going to put them into one. That is now integration. To integrate is to put into one. You see that? So that means my Vx will be the integral of from which points 1 to 3, 1 to 3, and then the whole of this. Then this delta x now becomes dx, because now we are seeing the bigger change in the values of x. Okay, now volume of solid of revolution rotated about the x-axis will be pi. Then we integrate from 1 to 3, then y squared, then dx. Okay, remember our y is, what was it? It is the square root of 2x squared, I mean x cubed then plus 10. So meaning y squared, then we shall square this one here, and then it gives us 2x cubed plus 10. So we shall have pi, then we integrate from 1 to 3, and then we have 2x cubed plus 10. Okay, then dx. So we increase the power by 1, then we divide by the new power. This will be x power 4. So we shall have 2, then x power 4, then out of 4, then plus 10 of x, and then this one will be 3, 1. Then you have here pi simplified. This one will be x power 4 over 2, then plus 10x. Now, what we are left to do is to substitute these values here. So we begin with the upper limit, 3 power 4, that is 81 over 2, then plus 3 times 10, that will be 30, and then minus, when you put 1, of course, that will be a half, then plus the 10. Okay, and then all together, this 81 over 2 minus a half, what will that give us? It will give us 80 over 2, which is 40. Not so. That will be 40. And then 30 minus 10, that will be 20. So we have a positive 20 here. So meaning the final answer is going to be 60 pi. As simple as that. If you want, you can put it to 3 significant figures, but leaving it exact is smart. That is that.